Hello and welcome, this is Edge with Scildburg.com. In this tutorial we're going to talk about FETs and MOSFETs. This is an IR540 FET transistor. The main difference between these and BJT is they work off of voltage rather than current, and they are also faster. This is a T220 package. It has metal. Sometimes these are nice because if they get too hot you can add a heat sink to them, like this one right here, so it doesn't overheat. But let's get started. Again, this is an IR540, and we're just going to put it in our breadboard right here like that. As you can see, I already have a voltage regulator, 7805, so it's going to put out 5 volts. 5 volts is coming from this line right here, and our rail is 9 volts. So we have a 9 volt rail and also 5 volts coming out of the voltage regulator. So we have our transistor here, and the first thing we're going to do is look at our data sheet, which I have open, and we can see that these pins going from left to right is the gate, the drain, and the source. Gate, drain, source. So what we will be doing, how we will connect it is, we will connect the source to ground, just like that, and we will connect our gate, which is the first leg, to our input voltage, which is 5, and that's going to compare, this transistor will compare the gate voltage with the source voltage. Source voltage is obviously 0 or close to 0, and the input voltage is 5. It's a little bit over the threshold of 4. It says not to go, the data sheet says not to go over 4. Not a big deal. It would have to be, I think it would have to be quite a bit higher than that for it to burn out or get hot. But in any case, if you're trying to be safe, follow the data sheet. But it has to be at least 2 volts. So there has to be at least 2 volts of power that goes to the gate in order for this transistor to open. Right now we have 5 volts going to it, so let's see how it looks. One more thing we have to do first is we have to connect a pull down resistor to pull the electricity out of the transistor after we turn off the power, because if we do not, the electricity will stay in there because there's a field, an electric magnetic field in there, and it'll just stay there. So it will stay on unless you have a pull down resistor which pulls it to ground. So what we are going to do is connect that to ground now. So this is actually open right now. So I'm just going to put the negative side of the LED to the drain. I'm going to add my resistor so I don't blow the LED. And what I'm going to do is take a wire from our 9 volt rail, which is still part of our circuit, and put it on the other end of the resistor, and the LED should light. And it did not, for some reason. Oh, there it goes. It's on. Just can't see it very well. Oh, I know why. I had a very big resistor on there. I had them. In any case, so we'll put our smaller resistor, and there we go. Now it's on. And again, so we have 5 volts going into the gate, and it is powering, it's letting 9 volts go through it. Now, the IRF540 will allow up to, I believe, I could look on the data sheet, but I think I remember it's 100 volts. So theoretically 100 volts could be going through this green wire into our LED if we had the power and we wanted to do that. Now obviously we can't have 100 volts on the gate. That's supposed to be a maximum of 4 volts, but we've got 5 volts going into it now. Not really any harm done. But as you can see, we can get a higher voltage going through the transistor and shut it on and off with a much lower voltage. So one more thing just to demonstrate how this will turn on and off, or the voltage is required. So we turn it off, and now because we have the pull down resistor, it shut the transistor off and our LED shuts off. So if you can watch here, without the pull down resistor, when we turn on the transistor and then we take off the 5 volts, it's still on because the electricity is still inside there, keeping the gate open. When we put the resistor back in, it will pull the electricity down to ground, and now it's off. You turn it back on, and it's on. Turn it off, off. But let's see how it works if we use this 2.2 mega ohm resistor here. So we're just going to put this over here somewhere, and we're going to take the 5 volts and put it into this 2.2 ohm resistor. And what we're going to do is just pull off this ground wire here, and we're just going to take a reading. And the reading I have is 0.88 volts. So that's the reading. So almost a volt. So we're getting some electricity through there, but let's see if that allows the gate to open the transistor. And as you can see, it does not. Transistor is not open because the voltage is not high enough. If we go back and put the 5 volts on it, it will open. Get it in the right slots. I don't have the negative, that's why. Let's go back. So let's try it with the 2.2 mega ohm and see if it turns on. And as you can see, it does not turn on because there is not enough voltage to turn on the transistor. So if we go back and we use the 5 volts again, it will turn on. And because we have the pull down resistor, it will turn on and off. And there you go, the FET MOSFET transistor.